Hi, I'm hw4question1. This is a video explanation for question 1 of homework 4. The first question asks us to find and draw the distribution function of y and the probability density function of y in terms of probability distribution, which is CDF of x, and the probability density function, which is PDF of x. We are given the function y. First of all, we need to draw the y. Draw gx. Here is 0. For x is less than 0, gx equals to 2. And we can change another color, 2. And for x is in the range of 0 to 1, gx is equal to 0. And for x is in range of 1 to 2, gx equal to negative x plus 1. And when x is larger than 2, gx equals to negative 1. Okay, that's it's a plot of gx. First, we can see that for the range of y is larger than or equal to negative 1, but is less than or equal to 2. So for y is less than minus 1, or y is larger than 2. For y is less than minus 1, the distribution function of y will always be 0. And for y is larger than 2, the distribution function of y is always 1. When x is in the range, when y is in range of negative 1 and 2, we have several conditions. First one is y equal to minus 1. Well, we can see from the plot when y is equal to minus 1, we can get the probability that y equal to minus 1, negative 1 will be the x is the range at x is larger than 2, so it's equal to the probability that x is larger than 2, which is 1 minus distribution x2. And for this part is 1 is larger than or equal to 0, but less than or equal to minus 1. is less than 0 but larger than -1. In this part, y equal to -x and then +1, so that the density function of y will be probability density function of x divided by mod g dash x, which is because x equal to we can replace x to y minus y, then divided by mod of -1, which is fx y minus y. And for y equal to 0, we can see that this part, the range of x is from 0 to 1, so the probability that the probability that y equals 0 equals to the probability that x is larger than 0 but less than y, which is fx1 then minus fx0. And for the range of 0 to 2, there is nothing. But when y equal to 2, the probability that y equal to 2, the range of x is less than 0. It's a probability that x is less than 0, which is x0. So till now we can we already get the density probability density function of y is the first part is y equal to -1 -1. The density function of y is 1 minus fx2. Y is larger than -1 but and less than 0. That's this. And third condition is y equal to 0. When y equal to 0, the probability density function of y will be fx1 minus fx0. Y equal to 2, fx0. And otherwise, it will be 0. You can draw it now. Let's see y is probability density function of y. When y is -1, it will be this. This area will be 1 minus fx2. And when y equal to 0, this area will be fx1 minus fx0. And when y equals to 2, this area will be fx0. And this part will be a density function of x when y minus 2, y minus y. Here is y equals 2. Then we can easily get distribution function of y. We have know that when y is less than -1, -1, it will be 0. And when y is larger than 2, it will be 1. Y is in the range of -1 and 0. It will be integral of this function, which is 1 minus fx 1 minus y. And when y is less than 2 but and less than or equal to 0, this is this part. This part will be 1 minus fx0. We can do it now. And this is CDF of y. -1, 1, 2. Here is 2. When y is larger than 2, it's always 1. When y is less than -1, it's always 0. And from 0 to from -1 to 0, it's equal to 1 minus fx 1 minus y. Here is a jump, which is 1 minus fx2 when y equals because the height is 1 minus fx1 minus -1, which is 2. And when y equals 0, is y is in range of from 0 to 2. It's always 1 minus fx0. So the height here is fx0, and here is 1 minus fx0. So that is the explanation for question 1.